happening or that has happened over the current century or so. So this is a very complex subject that is argued about extensively, between the two sides. There does not seem to be enough change in the solar radiation itself to explain the changes in temperature that occur, but there's some thought that there are other things involved in it, that there is cosmic rays that are blown away from the Earth by the solar wind and so forth, and that the solar wind is a means of amplifying some of the other changes that could occur on the sun. It's an extremely complex subject that they've been arguing about for years, and it has not been resolved to anybody's satisfaction yet. But it could go one way or the other.
So what happens if laws are passed internationally that there's going to be this attention to our carbon footprint? Now, since we're carbon-based life forms, and most plants and animals need carbon for life, including us, what is the translation of this new law or this new monitoring apparatus and this new focus that's away from carbon dioxide? What's going to happen?
Well, it depends upon how successful they are. I think it's going to be incredibly difficult for them to ever make much of a dent in the amount of anthropogenic CO2 emissions given off into the atmosphere. Countries in Europe that talk about it and so forth, they have not been that successful in reducing CO2 emissions. The CO2 content of the air continues to rise and rise. Places like China and India coming online, becoming more energy intensive, keep the CO2 concentrations rising. It's really going to be impossible to make any significant impact on it. And it is just going to be a tremendous drain of monetary means that could be used for other more beneficial things to help raise the standard of living in other countries much more rapidly, and then actually perhaps learn how to reduce CO2 emissions if they are so concerned about it by, making the transition less painful. But on the other hand, I truly believe that the CO2 content of the air should be allowed to rise. In other words, I think it should be allowed to take its natural course because of the benefit that will provide to humanity in terms of being able to produce more crops to feed the greater population we'll have in the future, and to enable us to not have to take a whole lot of freshwater resources and land away from the rest of the biosphere. I think that just letting nature take its course, and by including nature, I talk about also, human civilization and so forth. We are always progressing, and there are probably things that we will do to have different sources of energy in the future, and but I think that they should just come naturally. You know what I mean? Rather than trying to just change the way the world operates so rapidly when we're not prepared, to really do it.
There's a lot of new industrial applications for measuring CO2 in a person's home that are not only being made, but some are already done and ready to roll out to the public. Are you aware of that?
Probably not the ones you're speaking of. I know that there is instrumentation for doing that. In fact, I've measured the CO2 concentrations in my house over a period of a couple of years, a few years back. And it's interesting. You get very high concentrations inside of a house just from the people breathing in the house, and you can get several hundred parts per million more CO2 inside than you have outside. And of course, in an urban area, the CO2 that's emitted from various forms of transportation usually boosts the CO2 content of the air also. It sort of has a diurnal variation. during the evening when there is an inversion that occurs, the CO2 builds up in the lower level of the atmosphere, and you have sort of a CO2 dome that forms over metropolitan areas. But then in the daytime, when the sun comes up and starts heating the surface and gets convection going and mixing to higher levels, that kind of sucks it up higher into the atmosphere, and then the concentrations fall again. But CO2 is extremely variable in an urban environment and in almost any smaller place, too, when you go between inside and outside of your home. It's a lot higher inside your home than outside.
Do you think that people can actually control how much CO2 is in their home?
The only way you would control that would be as to how much ventilation you have between indoors and outdoors. And in the summertime, say you open your windows or something and get a little air moving through it, it drops it way down. But the fact that it's high in your home doesn't hurt anybody. You know, you have to get extremely high concentrations before it becomes harmful to people.
Well, give me an example of that. In other words, what is considered, what's the frame of reference for what's okay, what's good for you, and what's harmful?
You know, I would have to look up on my own website to see what the answer to that is. But I think you have to have several thousand parts per million before it begins to have a problem for human life, or probably any life. But I can't remember exactly the exact numbers. But it's nothing like you're going to get in the home. Normally it'll just be a few hundred parts per million higher than normal.
Wow.
And if you go into some place like an auditorium or a theater, and then where there's more people, probably get higher yet, maybe a couple thousand parts per million even.
How many people are involved right now and are going to your site, co2science.org, to really learn the science? How popular is it, and how's it going?
You know, I can't. Several years ago, we used to keep track of that, and I wish I could remember. I can't even remember what it was back then, and I don't know what it is now. Couldn't tell you.
Okay. I have a question about the whole thing about the sea rising. I noticed you have an article here called The Past Half Century of Sea Level Rise.
Uh-huh.
That was updated back in 2008, November. But what is the whole issue about the sea level rising?
Well, people are concerned that if the planet warms a significant amount, that you might start melting the Greenland and Antarctic ice caps, and if you were to melt all of them, you'd have a tremendous increase in sea level. But there's so much ice there, and it's so cold in these areas that it's a very, very slow process. And this is what the debate comes down to relative to that. Just how fast is this process? And a lot of the models suggest that it could become fairly rapid. But most of the real-world data makes that a questionable assumption. We do have some melting that's been going on in the Arctic. It's been warming there, and sea ice has been decreasing. But if you go down to the Antarctic, sea ice is increasing. And there has been no significant large increase in the rate of rise of the sea level. It could well slow down somewhat too. It can vary now and then, depending on various things, but we just don't see anything happening very rapidly. And especially, if it's not going to warm. I mean, it hasn't warmed now for the last 10 years or so, and
I don't think the public knows that at all.
A lot of
Sherwood,
people think they can, but
I don't think the public knows that it hasn't warmed in the last 10 years.
That's possible that they don't know that, but if you go and look at the data, I mean, you can go onto our website and you can access the databases, and you can look at what the globe has done over the last, I don't know, maybe years or so, and you can see there over the last...
Oh, the U.S. Historical Climatology Network?
That's one place. That just deals with the U.S. If you're looking at the website, let me get back to my home page.
So I'm looking right now. I'm trying to
Right up at the top, it says data,